Hello, today I wanted to work through this problem that I've already solved before in this channel with a different programming language. In this channel, I've worked with C++, C. Actually, I haven't done any C, not in this YouTube channel. Ruby, Java, and Python. But today we're doing this in Rust. So this is just a simple two-sum problem. You are given an array which is called nums, and then you're given a target number. You have to find the two indexes that add up to the number. So super easy. You go through the array and you find the two that add up to it. But the rule is you cannot use the same index twice. So you can't use two times to add up to six. You must use multiple indexes. As it says here, you may assume each input would have exactly one solution, and you may not use the same element twice. And that's basically all you have to do for this problem. And we're choosing Rust specifically because it is a hard to work with programming languages. And in my opinion, you learn more by working with hard programming languages. And once you get good with those, then other programming languages just seem easy in comparison. So if we do like a Google search, what are the hardest programming languages to learn? And we go here. Here ranks them, well, just some of them. And so the higher the number here before the slash, then the harder it is. So actually here the hardest one is for us. In my opinion, there's harder languages like assembly, which is also pretty hard to work with. But I would say Rust is slightly more complex. Also, C++ is kind of difficult, but once you get used to it, it's not that bad. In my opinion, Rust is harder than C++. It says it's perfect for coding Daredevil, seeking the thrill of systems programming with a safety net. Rust is fresh on the scene with the focus on safety and performance. It is challenging to learn, but rewards you with memory safety and the ability to handle multiple tasks effectively without data races. Let's just call it the safety conscience, the driver of the group. It aims to provide the performance of C and C++ while guaranteeing memory safety. That's why Rust is gaining traction in system programming, WebAssembly, and anywhere else where performance and safety are critical. Rust has a steep learning curve even for experienced programmers. Its unique approach to memory management and ownership can be a real head scratcher. I would disagree with that, but I do agree with the next statement. But for those who master it, Rust offers a powerful tool for building fast, safe, and concurrent systems. Its standout features are memory safety without garbage collection, concurrent programming without data races, modern syntax with powerful abstractions. This is, in my opinion, Rust's best feature as far as I've used it, but I'm fairly new to the language. So what I'll do here is I'll create a hash map. When you're creating a variable, you can use let. And then if you plan on modifying that variable, you need to include the mute, which stands for mutable keyword. And then after that, just the name of the variable. In this case, my variable name is just going to be the letter M. And I want to create a hash map. And then I'll just use the access operator to access the new function. And there you go. I have a hash map. And then after that, what we want to do is iterate through the uh, number array. And as we iterate through it, we're going to search for the two items, the two indexes that add up to our target. So here for this hash map, my plan for it is essentially is to add the index, the current index value as the key and the index as the value. So when we add the element, so here the element, for example, in index 0, the element is 2, we're going to add the 2 to the hash map as the key, which will get hashed. That way we can look it up quickly. So a hash is just a cryptographic way of storing something. But here the hash is done automatically. We don't have to actually worry about cryptifying or anything like that. That would be something that we would have to do manually with algorithms like maybe Rabin-Karp or Clint Morris. Um, we're going to do a for loop. I is going to be our index, n is going to be our value, and then in nums, which is our array, we're going to call iter that will allow us to iterate through it, and then enumerate, which will allow us to have an index. And then we just create the scope, and then we do for, oops. Well, we can do this two ways. We can iterate through the map. I can create another for loop and nest them. That's one option. But in that case, it's not really needed since we're not going to do a whole lot of logic. All we're doing is looking for the two indexes. So what we'll do instead, we're just going to look through the item that we need. And then at the end, if we don't find it, then we can just add the current item to the hash map. And remember, I said I is the value. I'm sorry, I is the index, n is the value. And then we're going to do some. This is actually specific to Rust doing something like if let some. If you remember, let just helps you create a variable. Um, but hopefully, you know what an if statement is. It's just creating a very tiny logic. But the beauty of this line is that it essentially works like an if else statement. So if you are able to create J based on the conditions that I'm about to provide, then the block executes. If not, then you and avoid that entire thing and you just move on. Like it'll just move on to create inserting here. Well, I haven't created or defined the block, so let's go ahead and do that. So we're gonna say to access our map, and we're gonna use get to look for the key, and we need to pass by value because if we don't, then we'll lose our ownership. Same reason why we're using these here instead of just iterating through nums. If we just iterate through nums without like these types of inbuilt functions, we will lose nums. We'll only have access to it once. Like we'll lose ownership of it, and then poof, it's gone. Like you have nothing there anymore. That's one of the weird things about Rust, which no other programming language has that inconvenience, but at the same time, it can be useful for certain things. So in here, we'll just nest another parentheses and we'll go ahead and look for the item. So, so we're going to go through our target and we're going to subtract our current value. So for example, if our target is 9, we are subtracting 2 and we're looking for if 7 exists on the hash map. Since this is the first item, it's not going to exist yet because we haven't inserted it. But when we go to 7, now we're at 7, for example, our target is still 9, and now we're subtracting 7 from it. So now we're looking for 2. And since we already inserted 2, as you see here, we're inserting them as we go through them, starting from the beginning, then it already exists in our hash map. And that's it. That's the main logic of this whole thing. And then we're gonna just return the vector. Well, it's really just a tuple. And here's another interesting thing about Rust when you're going to return something or use something like in a, even like a subscript, then you need to specify the type. In this case, we can use I32. I'm pretty sure we can also use U size, but let's use I32. We can use U size when we are trying to access the element, but for this case, we should use I32. And then the next one is going to be I as I32. And another quirk with Rust, or another interesting thing that you can do for the last line, which is supposed to be the return statement, in a function that does have a return statement that's not void, which this one is not. This is what it's expecting for you to return. This specifies the parameters. The parameters must also specify the data type. As you see here, it's not enough just to pass nums. You have to specify its type. And this is how you do it in Rust. In other programming languages, you would do something more friendly to the English language, like int and then target. But here it's a little bit different. And then the return statement must be followed by the parameters. So here it's a vector of items with I32. That's why we are filling our vector with J as I32 and I as I32. But at the end here, we don't have to like do return rec. I guess technically we could. Here I'm not going to return anything because if we reach this point, if the code reaches this, it means we failed. Um, you don't have to have a return statement, even if it's correct. If it's the last line in your function, then it's just automatically interpreted that it's the return statement, and you can just leave it like that, and it should work. It's like we're getting an error. Okay, it's because I misspelled it, probably. Let's see if it goes away. It says expected vector I32, but it found empty. Oh, that's because I added the semicolon. When you don't add the return statement, you cannot add a semicolon either. So I guess we can get away with doing this. And we can also get away with doing this, like I was trying to explain earlier. Okay, and that's it. As you can see, it works. Now we can submit against more tests, and it's pretty fast. Apparently, it's not very memory efficient, but that's fine. At least it's very fast, which I'm happy with. But that was it for this video. Just a brief introduction to what Rust is and a very simple problem, I would say, in Rust. In other languages, for simple problems, you usually don't have to call inbuilt functions or even use like hash maps. Um, but for efficiency, I did use it. I hope this was a good explanation. If you have any questions, just let me know. And again, thank you.